Alright, what's up guys? In this video we're going to pick up with some calculus here, and we're going to be talking about logarithmic differentiation. So we're going to use logarithmic differentiation to find the derivative of this given function. So we're given f of x is equal to x raised to the x. So maybe a little weird looking function. Now remember, f of x, that's the same thing as y, so I'm just going to write it as y is equal to x raised to the x. So the way you do logarithmic differentiation, we'll begin by just taking the natural logarithm of both sides. So I'll take the natural logarithm of this side, I'll take the natural logarithm of that side. Okay, so that's what you start out by doing. Now remember, anytime I have something like ln of x raised to the y, that's basically just going to be y times ln of, in this particular case, x, which would be the base. Or if you want to think about it as, let's say I have ln, instead of maybe using x and y, let's say I have ln of a raised to the b, for example, then it would just be equal to b raised to the ln of a. Maybe that's a better way to write it. And so essentially what we'll get is ln of y is equal to x times ln of x. So hopefully you're with me on that so far. Okay, so not very much work to do with log properties or rules or anything like that to start. Some problems will be different than that, so be prepared to do a little bit more work before you can differentiate. But in this case, we can go ahead and get started with the differentiation. So we'll go ahead and differentiate both sides with respect to x. And differentiate this side as well, x times ln of x. Okay. Alright, so this is obviously 1 over y times dy over dx. And then to differentiate this side, I have to apply the product rule. And in that case, we'll get ln of x plus 1. Because remember, when I use the product rule to differentiate this side over here, I'll get ln of x plus x times 1 over x, which will obviously just, the x's will cancel out, just giving us a ln of x plus 1. That's where that came from. Then we'll multiply both sides by y, and we multiply both sides by y, we'll get dy over dx is equal to y times all of that stuff, ln of x plus 1. Now remember what y was. Y was x raised to the x. Keep in mind f of x, and I always have to remind people of this, f of x, that's the same thing as y. So just keep that in mind. So all we really have to do is just plug that back in there, and that'll be it. So the final answer for this using logarithmic differentiation, we can just say that f prime of x is going to be x raised to the x multiplied by ln of x plus 1. Simple. Alright, so if you got any questions about this, let me know. This is a relatively easy example of logarithmic differentiation. They won't all be this easy. Like I said up there, we really only had to apply one log rule or log property, however you want to say it, to really get down to the point where we could differentiate both sides. But be expected to do more work. This was just a relatively simple example. But that's how you do it. So let me know if you got any questions about it. I'll see y'all next time.